Okay, this section here will be on identifying alcohols, ethers, and phenols. Um, they both have their distinct properties, but they look almost exactly the same in a molecule, so it's important to be able to understand the difference. I have the three definitions right here written. An alcohol is just an OH group attached to an alkane-like structure. So the big thing you need to notice here is it's an OH group attached to like an alkane structure. Like the whole structure does not need to be an alkane, but just the structure that's right next to what the OH group is attached to, that's all that matters. That will make the compound an alcohol. And then we have an ether. That is a lone oxygen atom that's sandwiched between two carbons. The thing to remember here is that there will be no hydrogen bonding on the oxygen atoms, and that's why when Dr. Goodall talked about boiling points, the boiling point for these will be much lower because since there's no hydrogen bonding, there's not much intermolecular force keeping these stuff together. So this is important to remember as well. So just remember that there's oxygen atoms being sandwiched between carbons. And then the definition of a phenol is that there's an OH group that's attached directly to a benzene ring. The important thing to remember here is the OH group must be attached directly to the benzene ring. If the OH group is attached to something else that's not on the benzene ring, it is not a phenol. So that's something very important to remember. I have 6 examples here. The first example, this one right here, we just have our OH group attached right here. We'll just go through our definitions here. Alcohol, OH group attached to an alkane. Looks like we have an OH group. This looks like an alkane. The whole thing is, so we don't need to worry about it. So OH group attached to an alkane, this must be an alcohol. We can stop right there. The next example, we have a different structure here. It's OH attached to a cycloalkane. Let's see, let's look at the definition of alcohol. It's an OH group on an alkane. This is an alkane. Well, it's a cycloalkane, but same thing. We have our OH group connected directly to it, so this is an alcohol. Our third example, we have a benzene-like ring here. We have an OH group, and it's attached directly to the benzene ring. So let's look at alcohol, OH group on an alkane. This is not an alkane, so it's not an alcohol. Ether, it's an oxygen atom sandwiched between two carbons. Here's an oxygen atom that's sandwiched between a hydrogen and a carbon, so it cannot be an ether. So phenol, OH group attached directly to a benzene ring. OH group attached directly to a benzene ring. This is a phenol. Next example down here, we have an OH group attached to a methyl, which is attached to a benzene ring. Let's just go through our definitions. Alcohol is an OH group on an alkane. This is not an alkane, so it cannot be an alcohol. Or can it? Because remember what I said earlier, it has to be directly attached to the alkane. And as far as this one is, it's directly attached to an alkane-like structure. So we don't have to count what this is, we just have to count what this is back here. So technically, this right here is an alcohol because we have an OH attached to a alkane-like structure. Even though this is not an alkane over here, the immediate carbon right next to it is alkane-ish. So this is actually an alcohol. You must keep that in mind. Our next example, here's another tricky example. We have a O here and a CH3 here and a benzene ring here. Let's look at our definitions. We have alcohol, that's an OH group on an alkane. We actually don't have an OH group here, so it cannot be an alcohol. We have an ether. It's an oxygen atom sandwiched between two carbons, and there's no hydrogen bonding. Let's see. Here's our oxygen group. It's sandwiched between a carbon here and a carbon here. No hydrogen bonding. So this must be an ether. In our last example, let's find the oxygen atom. It's right here. We have an oxygen atom sandwiched between two carbons. This hydrogen right here is attached to this carbon. So this oxygen is attached to two carbons. No hydrogen bonding. It must be an ether.